Hello dear students, today I am going to give you one important hint so that you will not go wrong while solving the problem based on resistance. Most of the students they will say, no sir, I have solved it exactly correct. They will be saying their calculations will be correct, everything will be correct. But in the beginning, very first step will be done wrong. For example, coming to this circuit, if you look at the circuit, what do you see, find here? These are in parallel, right? Here, these are also looking like parallel, right? Yes. Here, resistances, these are in whatever numbers are given, same type of resistances. Here also same type of resistances. Okay. R1, R2, R3, R4, R4. Both are same in both the cases. And potential difference here 12 volt, here also 12 volt. That is also correct. But when you calculate, this is entirely different. This is entirely different because in this circuit, all the resistances are connected in parallel. Okay, whereas in this circuit all the resistances they are not connected in parallel. 1 and 2 they are connected in parallel and 3 and 4 are connected in parallel. Then how to know this? It's a very simple trick. If you follow that, easily you can guess whether it is completely parallel or parallel and series combination is there. You can easily identify. Say for example, here if you take, just you try to remove anything, any means any one of the resistor or all other leaving one. Each resistor is directly getting the connection from the source of electricity. So here each resistor R3, R4, R2, R1, whichever you take, that is directly connected to the source of electricity. That is why all the resistors are in parallel. If you remove one, it is not going to affect the other three. Now you see, coming to this case, what is happening is here R1, R2, R3, R4 and so on. Means all the four resistors they are connected. How they are connected? Here R1 and R2 they are in parallel. Okay, this whole set it is running through one more set. See here R3 and R4. If you stretch and keep here, that will be different. Say for example, this becomes what? I'll show you here. If you stretch this comes like this. See, right? See, this set is in series again. Okay, look at this. Now if you find these, what this is total resistance parallel here. This is also parallel connection, but both are in series. So you'll have to go for RS for effective means equivalent resistance. So what you can do is here for this, if you want total RP, what you have to do, first one you can take this as RP1. So RP1 will be R1 plus 1 by R1 plus 1 by R2, and RP2 you can take this as RP2. This will be RP2 is equal to 1 by R3 plus 1 by R4. Right, like this you have to take total equivalent resistance. If you want, what you have to do, you will find out RP1 RP2, so that will be the sum. That sum will be given by RS means equivalent resistance, remember. Okay, so here these are in series connection. Coming to this, here all are parallel connection here. So what you can do, directly you can go for this one, 1 by RP equal to 1 by R1 plus 1 by R2, once 1 by R3 plus 1 by R4 you can do. Otherwise, you can break this like this also. This set you can do once if you want. 1 by R1, 1 by RP1 is equal to 1 by R1, R2 you can make. This sum you can find out. Next in the same way, this set also you can find out. But since this set and this set both are again in parallel connection, how to find out the total equivalent? 1 by RP is equal to, here 1 by RP1, this one you need to take, again 1 by RP2, like this one you need to take. So once if you do this, you are going to get RP here. Okay, here RP you are getting. Okay, means what? Resistances in parallel. So it's equivalent resistance you are finding here. Once if you find out that, easily you can get the current I is equal to phi by RP. Here also RS equivalent resistance, once if you find out, easily you can find out I is equal to phi upon RS. If you calculate, you will get current in amperes, right? So easily you can calculate this. If you try this, whether you can get the correct answer, right answer, you comment that your answer in the comment box, so that I can, when I solve the resistance problems on resistances in the next video, then I'll take up this first. If yours is right or wrong, we can confirm and go ahead. Okay, thank you for watching.